Hi everybody. This will be a continuation of our 4.2 notes that we had started in class. So I'm going to call this 4.2 Day 1. Continue. So this will help with any of the questions where you see what we are going to call cubics. And I know you are familiar with that word. When you hear the word cubics, what do you think about? Highest exponent of, drumroll please, what number? Highest exponent of 3. So that's what these notes, this little section of notes, is going to help us to learn more about. So when we are working with cubics, specifically cubic binomials, what does binomials mean? It means two terms. So just cubic binomials, where we only have two terms. There are two special cases we are going to talk about as part of our notes today. Sum of two cubes. Let's talk about that one first. What does sum mean? Sum means addition. So when we have a cubed plus b cubed, notice these threes, that other three could be a little higher. Make sure that that exponent is clearly high. A cubed plus b cubed. This will always factor to be a plus b times a squared plus ab. My bad, back that up a little bit. A squared minus ab, I'm sorry, plus b squared. And then we also have the difference of two cubes difference referencing subtraction, so a cubed minus b cubed. It's almost going to look exactly like this, but there's one shift. We'll see if you notice what it is. It's a minus b, a squared plus ab plus b squared. So once you finish writing that down, my question is, these are super alike. There's just a little bit of a difference. Do you see where it is? I'm hoping we're noticing that the only difference between these two is the location of the negative. Here it's a plus b and then a squared minus ab. Here, when it's the difference of cubes, it's a minus b first. So these are the two equations we are going to work with. The only note that we need to make is that the resulting quadratic will never be able to be factored further. And the quadratic we're talking about is right here. These quadratics will never be able to be factored further. And we'll see what that will look like when we do some examples, which we are going to do right now. Just gonna make these colors match. We have 4 examples to look at. Number 1, x to the third plus 8. So I'm hoping we recognize 8 from our chart knowledge from the last unit, because we can rewrite this to be x to the third plus 2 to the third. So notice this is the sum of two cubes because x cubed is a cubed term. and 8 can be rewritten as 2 to the third. So this means that A is x and B is 2. And for the sake of the notes, I'm doing this here to make a connection to this A and B, but over time you may get comfortable where you don't need to write that. So for the sake of the notes, again, I'm going to rewrite what this becomes. So we're looking to write A plus B, A squared minus AB plus B squared. And the more you write out the general form, the more you will remember what this is. So A is x and B is 2. Let me say it again. A is x, B is 2. So this becomes x plus 2 times A squared is x squared minus AB minus 2x plus B squared. 2 squared is 4. That's it. That's as far as we can go. Because quadratic automatically not factorable. Which means if I asked you for the exact values, you would need to use the quadratic formula. So that's as far as number 1 can go. Let's look at another one. Number 2. 27x cubed minus 64. And that's it. I'm used to saying more. Those are our only 2 terms. 27x cubed minus 64. So the question is, how can this be rewritten as the difference of 2 cubes? I have 2 terms, so that's a plus. 27, chart knowledge, 27 is what to the third power? 3 to the third is 27, and x to the third is x to the third. So I can rewrite that first term as 3x all cubed. Chart knowledge one more time. What to the third power equals 64? What to the third power equals 64? Is there anything? Let's see. 1 cubed is 1, 2 cubed is 8, 3 cubed 9, 4 cubed, remember that's 4 times 4 times 4. 4 times 4 is 16, 32. Oh, will that work? Let's see. So 4 cubed becomes what we need for A cubed minus B cubed. So again, if it helps, let's write A equals 3x, B equals 4, and that's what we're going to use with our general model, A minus B, A squared plus AB plus B squared. So A minus B becomes 3x minus 4, and then we've got A squared, so that will be 9x squared plus AB plus 12x plus B squared plus 16. That's as far as we can go. Again, because this quadratic is not factorable any further, you need to use the quadratic formula to keep going. 2 more examples. Number 3 says 16u to the 5th minus 250 u squared. And I bet you some of you were like, Miss J, you said the highest power could only be 3. And I was telling you the truth, because take a close look, and what do you see can be factored out? Well, at a minimum, I've got 5 u's here and 2 here. So at a minimum, I know I can factor out u squared. 16 and 250, do those share any common factors? Well, if you're not sure, grab your calculator. See, I'll take mine out. I know 250 is divisible by 16, so let me try 16 first. 250 divided by 16. Nope, that didn't work. How about 250? Did I do divided by 16? Yeah, that didn't work. 250 divided by what else? Maybe 8? Nope. How about 250 divided by 4? That didn't work either. How about 2? I know that one worked because they're both evens. Hey, look at that. I can take out a 2. So let's factor out 2u squared. That will leave behind 8u to the third minus, what's half of 250? 125. And now the inside is something I can keep going with. And my goal is that from chart knowledge, we're like, yes, I can do something with 8. And yes, I can do something with 125. This is the difference of cubes, where A will be what? And B will be what? Take a shot. See what you say A and B will be. Did you get that? A and B will be. So A will be 2u, because 2u all cubed is what that really is. 2u all raised to the third power. So my A value is 2u. And then B is 5, because 5 to the third power is where that 125 comes from. Again, this is the difference of cubes, so we are using A minus B, A squared plus AB plus B squared. Now here we have to remember that this 2u squared is a GCF that will stay out front. So what I mean by that is it's going to stay right here in the front of what we're about to write. So I've got A minus B, which will be 2u minus 5, A squared, 4u squared, minus, or excuse me, plus, so A squared plus AB, so plus 10u plus B squared, which is 25. And that whole thing will be my answer. Again, making sure the GCF stays out front. Last example for these notes, number 4. X to the third, y to the sixth, minus 64. Clearly we have a GCF situation. Possibly. Do we? It's so tempting, right? So that's why I said clearly at first, to guarantee you somebody was thinking about it. But this term has x's and y's. Does this term? No. So, strategy, can you somehow rewrite this to be in this form? Press pause, give that a try. Well, if I kind of work backwards from what this is, again, I'm looking to fill these parentheses in. X to the third, so that just means a single x comes in here, because then if I sent in this power, that would become x to the third. Y to the sixth would come from y squared to the third power, because 3 times 2 is 6. So here's my a value. This whole thing right here. xy squared. It's an ugly y. I want to fix it. And b is 4, because 4 cubed is 64. Give it a try on your own. Remember, you are writing your general model. We're going to write it over and over and over again until it becomes muscle memory. A minus b, a squared plus ab plus b squared. Press pause, give it a shot, and then we'll check answers. So a minus b becomes xy squared minus 4. a squared. So if it helps, write yourself an in-between step. xy squared, so that's a squared, minus ab, which would be minus 4xy squared, plus b squared is plus 16. So I just need to do this part right here. So like I said, in-between steps can help a lot. Sending in the 2. My final answer will be xy squared minus 4, x squared y to the 4th minus 4xy squared plus 16. So that wraps up our day 1 notes. On your day 1 and 2 homework worksheet, go check out any difference or sum of perfect cubes and give those a try. See you tomorrow.